Hey guys, welcome to this video on the 2019 Level 1 Mechanics video. So question 1, a boat travels across a lake to the start of a walking track. The graph below shows the boat's journey. Question 1a, describe the motion of the boat during each section of the journey. So as you can see, this is a speed time graph, and section A goes from 0 seconds to 400 seconds. So this section A from 0 seconds to 400 seconds, and as you can see, the speed increases from 0 meters per second to 3 meters per second in 400 seconds. Because the speed is increasing over time, that also means that this boat in this case would be accelerating because the speed is increasing as over time. So when we say describe, we're just going to be saying section 1, we're going to say it's a constant acceleration because it's a straight line. And a straight line means that for each second there is the same amount of acceleration. If it was a curved graph, then it will be a non-constant acceleration. So for section A, we're going to say that the motion of the boat is a constant acceleration. Alright, for section B goes from 400 seconds to 700 seconds, and in section B, the speed remains constant at 3 meters per second, so it doesn't change. When the speed doesn't change over time, that means that it's maintaining a constant speed. So for section B, we're just going to say constant speed. Alright, for section C, it's from 700 seconds to 800 seconds, and the speed decreases from 3 meters per second to 0 meters per second. Because the speed decreases over time, we're going to say that this is a deceleration. And however, also to note that this is also a straight line, which means that the deceleration is constant. So for section C, we're going to say it's a constant deceleration. Alright, that's question A. In terms of question A, I do believe this is just an achieved level question. Although I'm not sure because I don't have the assessment schedule once again. So question A, I'm thinking is just for all three of these is correct, is for an achieved mark. Question B, calculate the acceleration of the boat in the first 400 seconds. So in the first 400 seconds, that's section A. And then section A, we've already covered that it is a constant acceleration. And we want to calculate what this constant acceleration is. So we have, so in this question, we're going to write down all the variables we have. We have the time is 400 seconds. And we have the change in speed. Change in speed is equal to 3 meters per second because it goes from 0 meters per second to 3 meters per second. So the change in speed was 3 meters per second. And now we're trying to find the acceleration. So in this case, as you can see in the formula sheet on top here, we're going to be using the acceleration equals to change in v over change in t to find our acceleration. So we're going to say acceleration equals to change in v over change in t. So therefore, our acceleration is equal to 3 divided by 400. So 3 over 400. That gets you an acceleration is equal to 7.5 times 10 to the power of negative 3 meters per second per second. So acceleration is 7.5 times 10 to the power of negative 3. And once again, I believe this is just an achieved curriculum level, so achieved for this question. Alright, question C. Explain the acceleration and the motion of the boat shown in section B of the graph by discussing the horizontal forces acting on the boat. So once again, section B is from 400 seconds to 700 seconds, and this was the portion of the graph where the boat was going at a constant speed. When the boat is going at a constant speed, that means there is no acceleration. So when there is an acceleration, there has to be an unbalanced force. However, because in this case there's no acceleration, that means there are no unbalanced forces. So that means that the boat's going to be giving up a forward thrust force, and there's going to be a backwards drag force that opposes the thrust force from the boat. Because the boat is neither accelerating or decelerating, it's at a constant speed, this means that both of these forces must be equal. So both forces in opposite directions, they cancel each other out, so therefore the net force is 0 newtons. So for this question, we're gonna say that the boat is moving at a constant speed. This means that there must be no unbalanced forces. So we can talk about the thrust force of the boat, the forward thrust force from the boat. The forward thrust force of the boat must be equal to the drag force from the water. Which acts in the opposite direction. Okay, so it's equal to the drag force and in opposite directions, which means they cancel each other out. So that's all you should need to write for this question. I believe this is a merit level question, and in order to get an achieved, I'm thinking that if you mention up to the no unbalanced forces here, so if from the starting sentence, the first sentence, if you can mention that should be an achieved level curriculum. And to get a merit level grade, I think you need to include everything in this paragraph to get a merit level grade. Question D. Show the distance traveled by the boat is 650 meters. So because this is a speed time graph, we can use, in order to find the total distance, we can use the area of the graph in order to do this. So basically, the total distance covered by the boat would just be the total area of everything that's underneath the graph. So all of this, it would be the total distance. So this is just basically a bit of a calculation math question. So the easiest way to do this is to split your entire, so this is a pretty weird shape right now, but we can split this into 3 recognizable shapes. So the easiest shapes to work with are triangles, rectangles, or rectangles and squares. So as you can see in this diagram, we can easily split this whole journey into 3 different components. So section A, section B, and section C. So in order to do this, we can, as you can see, we can create a triangle by dotting down here, and another triangle by dotting down here. So as you can see, this creates a triangle, a rectangle in the middle, and another triangle at the end. So this makes the calculation a lot easier, so you can work with basic geometrical shapes. Alright, so now it just comes down to calculating the area. So we know that the area for a triangle, so triangle, that's triangle. The area is half base times height, okay? So for section A triangle, we have the base is 400, so time is 400 seconds. When you have a height, the height is 3 meters per second. So 400 times 3 is 1,200, and divided by 2, this means that this whole thing is 600 meters. From section B, that's 400 seconds to 700 seconds. So the area of a rectangle, so rectangle is just base times height. So 400 to 700, that's a change in time. The change in time is 300 seconds, and then the height is still 3 meters per second. So we're gonna calculate as in 300 times 3, which is 900 meters here. For section C, it's another triangle, so we're going to use our triangle is half base times height. The base is 100 multiplied by the height, which is 3 meters per second again. So that's 300 divided by 2 is 150 meters for section C. And if you add these three distances, you should get your answer of 1,650. Yeah, so 600 plus 900 plus 150, so total is equal to 1,650 meters. So in terms of answering the question, you can say that the easiest way to word this question, you can say total distance traveled is equal to the area under the graph. So you can split it up into three sections. So you can say section A is section A. You can say that it was half of 400 times 3, which equals to 600 meters. Section B was 3 times 300, which is equal to 900 meters. And finally, section C was 100 times 3 divided by 2, which is 150 meters. So you can say that the total distance is equal to 600 plus 900 plus 150, which equals to 1,650 meters. And that should be your final answer for this question. And this question, in previous years, normally calculating the distance, this is normally an excellence level question. So up to here, I think that's an excellence level grade. In terms of getting a merit could be, it's a tough one. So achieved could just be working out one section. So working out the distance traveled in one section could be achieved. And a merit could be a merit, it's a tough one, I'm not too sure. A merit could either be a minor error, or it could be working out two sections distance traveled. So either or, I'm not too sure, but yeah, I don't have the marking schedule with me, so it's pretty hard for me. So sorry, guys. All right, question 2. Okay, so an adult and a child's feet sink into soft sand. The footprints are the same depth. The child's footprints cover a smaller area than the adult's. Question A. Pressure is defined as the force exerted divided by the surface contact area. Using this pressure definition, explain how it applies to the adult standing in the sand. So when the adult is standing in the sand, the adult's weight force is distributed in his 2 feet, which is in contact with the ground. This weight force is distributed in 2 feet, which causes because it is soft sand. This will cause a footprint and footprint in the sand. So you can say that. So for this question, you can say using this pressure definition. So you can say the weight force of the adult. The weight force of the adult is in his or her 2 feet. This feet is in contact with the sand. So you can say that this is the surface contact area. Which the feet is in contact with sand, which causes footprints. So that should be your answer for this question. So the weight force of the adult is distributed in his or her 2 feet. This feet is in contact with the sand, so that is the surface contact area, and this would cause the footprints to be formed. So the feet would sink, and then the footprints would be formed there. So for this question A, it should just be an achieve level question. The surface area of one of the adult's footprints is 200 centimeters squared, which is 0.02 meters squared. And the surface area of one of the child's footprints is 150 centimeters squared, which is 0.015 meters squared. The adult has a weight of 690 newtons. Show that the total pressure the adult exerts on the sand is 17,250 pascals. Okay. For this question, we have a weight force. Okay, so we can say that this 690 newtons, that's the force exerted. So the force is 690 newtons. And the surface area of one of the feet is 0.02 meters. So we can say that the total area is equal to 0.04 meters squared. And I'm trying to find out the pressure. So the pressure exerted. So this question, we're going to be using the relationship of pressure equals to the force distributed over area. So we can say that pressure equals to force, which is 690 newtons, divided by 0.04, which is the area in contact with the ground. So 690 divided by 0.04, and that does indeed give us 17,250 pascals. And that's it for this question, and this is just a one-step calculation, so this should just be another achieve question, achieve mark. So question C, explain how the footprints are the same depth, although the mass of the child is smaller. In your answer, include a discussion of pressure, surface area, and mass. Alright, the mass of the child is smaller, but because the mass of the child is smaller, another thing to keep in consideration is that his or her feet is also smaller, which means that the total surface area in contact with the ground is also smaller. That means that even though it is a less weight, it is also distributed over less surface area. For the adult, it would have been more mass, but it would be distributed over a larger area. So because of this, the child's weight force is distributed over a smaller area. That causes the footprints to be the same depth. Explain how this. Okay. So you can say, all child. The child's mass. So although the child has a smaller mass, the child's mass is distributed over a smaller surface area than the adult. So because pressure, sorry, it's really unneat writing, so because pressure equals to force over area, but this causes how am I gonna word this? The child has smaller force or smaller weight force would be more appropriate. There's a smaller weight force, but smaller area. This causes the differences to cancel out, I guess. And hence exerted by the child is equal to explain how the footprints are the same depth. Okay, so basically you can say that pressure is proportional to the distance that the footprint is. So you can say pressure. Okay, so basically the more pressure, the deeper it will sink. So however pressure is the same. Hence pressure. However, the pressure is the same. Hence the feet sink the same amount. And that will be it for this question. So, although the child has a smaller mass, the child's mass is distributed over a smaller surface area because the child has smaller feet. Because the pressure equals to force over area, the child has a smaller weight force because has a lower mass. This causes, so basically, as you can see in this formula here, so pressure equals to force over area. The force is decreased, but the area has also decreased. So basically, if you're looking at from this in a mathematics point of view, so you can say that the numerator decreased. So if it's just the numerator decreasing, then the output would also decrease. But if only the denominator decreased, then the output would increase. So if they both decrease, then these two differences, they'll cancel each other out, and the output will remain the same. So in this case, the output remained the same. So you can say the differences cancelled out, and hence the pressure exerted by the child is equal to the pressure by the adult. More pressure means that the feet would sink more, because you're applying. It's hard to explain in words, but more pressure means that the feet would sink more. However, pressure is the same, hence the feet would sink the same amount. Alright, so for this question, this should be an excellence level question. Okay, don't quote me on that, but I think this might be an excellence level question. And if you get everything up to everything in this paragraph, that should be able to get you an excellence grade. To get a merit grade, if it's just up to this point here, I'm thinking that's just a merit grade. And to get an achieved grade, perhaps even just up to here could get you an achieved. Alright, question D. Both the adult's and the child's footprints are the same depth. Calculate the mass of the child. So basically, because the footprints are the same depth we covered in the previous question, this means that the pressure exerted by both the adult and the child must also be the same. So basically, in this question, we can say that sorry, not red pen. So we can say that the pressure of the child is equal to the pressure of the adult. And we also know that pressure equals to force over area. And we're trying to find the mass of the child. So mass of the child, we're trying to find. Alright, so if we come back here, the child's footprint is 150 centimeters squared and the adult's footprint is 200 centimeters squared. So we're going to be looking at the total surface area. So the total surface area of the adult is 0.04 meters squared and the total surface area of the child is 0.03 meters squared. So we're going to note that down in our question. So we'll say that so we know that, so we also know, sorry guys, so we also know that the adult has a weight of 690 newtons. So that's another thing we can note down. So we note down our variables. So we'll say that the force of the adult is equal to 690 newtons. We know that the area of child is equal to 0.03 meters cubed, and the area of the adult is equal to 0.04 meters cubed. Alright, so we know that the pressure of the adult can be calculated using this weight force divided by the total area of the feet. Okay, so we can say that the pressure of the adult is equal to 690 divided by 0.04, which equals to 17,250 pascals. And that means the child also exerts 17,250 pascals, so we can use this and substitute to find the weight force of the child. So we can say that 17,250 is equal to the force of the child we don't know over the area of the child's feet, which is 0.03. So our force would be equal to 17,250 times 0.03. And that equals to 517.5 newtons. However, we're not quite done because the question asks for the mass of the child, which means we have to convert this to kilograms. So we know that the force of the acceleration of gravity towards the Earth is 10. Is it 10 in level 1? I can't remember. It's 10. Yeah, gravity is 10. So therefore, we can find the mass of the child. So 517.5 divided by 10 is equal to 51.75 kilograms. And that would be your final answer for this question. This could either be a merit level question or an excellence level question. I'm not too sure which, if it's merit or excellence, but if it was excellence, then getting up to a final answer will get you an excellence grade. Finding the weight force would get you a merit grade, and an achieved grade could be setting up the equation perhaps might get you an achieved. Right, question E. The adult's weight force does 21 joules of work on the sand. Calculate the distance that the adult's feet sink into the sand. Alright, so we know that the weight force does 21 joules of work on the sand. So we know that the weight force is equal to force times distance. When F in this case would be the weight force. So we know that force equals to 690 newtons. Distance we're trying to find, and we know that the work is equal to 12 joules. So therefore we can just do a one-step calculation. So 12 equals to 690 times of the distance. And that gives us a distance of 0.017 meters. And that is that's rounded to 3 decimal places. So rounded to 3 decimal places. Because this is just a one-step calculation, this might just be an achieved question. Again, I'm not too sure about this one, but I think because it's just a one-step calculation, that it's just an achieved question. Alright, question 3. A parachutist with a total mass of 63 kilograms jumps from a plane. Show that the parachutist's gravitational potential energy when the plane is 3,500 meters above sea level is 2,205,000 joules. Alright, so we're going to note down our variables again. So our variables is going to be, we know the mass is equal to 63 kilograms. And we also know that the distance above the ground, so distance above the ground is 3,500 meters. So in this case, we're trying to find the gravitational potential energy, so our EP. So we know that EP is equal to mgh, where g equals to 10, the acceleration of gravity. And we actually have all our variables because we know that gravity equals to 10 meters per second. So therefore, we can immediately do a one-step calculation to find our EP. So EP equals to 63 multiplied by 3,500 multiplied by 10. And that indeed gives us 2,205,000 joules. And because this is just a one-step calculation, this should be an achieved question. Question B. A parachutist falls a distance of 450 meters during the first 9.49 seconds. Calculate the average speed of the parachutist during this time. So once again, our first thing to do, we're going to be noting down our variables. So he or she fell a distance of 450 meters. And the time taken to fall 450 meters was 9.49 seconds. And that looks like a 5. Okay, and we also want to find what the average speed is. So therefore, we're going to be using the relationship of v equals to distance over time. So we know that v equals to change in distance over change in time. So therefore, v equals to 450 divided by 9.49. And that gives an answer of 47.42 meters per second. And once again, it's just a one-step calculation, so just be an achieve mark again. Alright, question C. Explain the vertical motion of the parachutist immediately after jumping out of the plane. So that's before the parachute opens. In your answer, you should describe the vertical motion of the parachutist, describe the net vertical force, and state whether the forces are balanced or unbalanced. Explain how the net vertical force affects the vertical motion. Alright, so when the parachutist jumps off the plane, so immediately there's going to be the force of gravity acting on the parachutist, and that's going to be acting downwards at 10 meters per second per second. As the parachutist falls, he or she is going to develop an air resistance, and this air resistance will oppose the force of gravity that goes downwards. So the air resistance opposes gravity. At the start of the fall, gravity is a lot stronger than the air resistance. So at the start, the air resistance is very, very small, and the gravity is just 10 meters per second, which is much larger than the air resistance. This means that the forces will be unbalanced because the forces acting down is much greater than the forces acting upwards, and that means the parachutist is immediately going to start accelerating downwards. So, but as he or she falls downwards, the air resistance is going to get stronger and stronger. So as this air resistance gets stronger and stronger, the forces become less unbalanced because the difference between the gravity force and the air resistance is smaller and smaller as the parachutist falls down. This means that after some time, the parachutist is still going to accelerate downwards, but she will accelerate slower than when she was accelerating at the very top. After some more time, the air resistance is going to come to a point where the air resistance is exactly equal to the force of gravity. So at this stage, the forces are balanced, and this means that when the forces are balanced, that means the parachutist will no longer be accelerating and will just start falling at a constant speed downwards. And the scientific term for this motion is called terminal velocity, and that refers to the maximum speed of the falling object due to air resistance. And at this point, it's going to be not accelerating. It's just going to be the parachute is going to be traveling downwards at a constant speed. Alright, so to put this into words, we can start off with when the oops, sorry guys. How do I get rid of this? Okay, thank you. Meaning that the forces are unbalanced. So initially the air resistance is much smaller than gravity. So air resistance acting upwards. This means that right, so you can say after some time, Alright, so when the parachutist jumps, there is a force of gravity acting downwards. Initially, the air resistance, which is always acting upwards, is a lot smaller than the force of gravity, and this means that the forces are unbalanced because gravity is much stronger than the air resistance. This means that the parachutist will accelerate downwards. After some time, the air resistance increases, but the force of gravity is always the same because it's a constant. And this means that the forces are now less unbalanced, so the forces are still unbalanced, but it was less unbalanced than before. And this means that the parachutist will still accelerate downwards, but this acceleration rate will be a lot lower than before. So eventually, the air resistance will be equal to the force of gravity. This is called terminal velocity, and the parachutist is traveling at the maximum speed. The forces are balanced, and the parachutist travels at a constant speed, constant speed downwards. Alright, so for this question, this should be an excellence level question. So writing all the way from the start to finish should get you an excellence grade. To get a merit grade, if you can just talk about maybe up to here, that should get you a merit grade. To get an achieved grade, perhaps just up to here could get you an achieved. Alright, question D. During the 450-meter fall, the parachutist's gravitational energy was reduced by 283,500 joules. Calculate the parachutist's downward speed vertical at 450 meters, assuming energy is conserved. Alright, so the parachutist is going to be on the plane and she's going to jump down. When she jumps down, at the start, she has a certain amount of gravitational potential energy. However, as she jumps from the plane, this gravitational potential energy will be converted into kinetic energy. When it's converted into kinetic energy, so when the gravitational potential energy was reduced by 283,500 joules, we're going to be assuming conservation of energy, which means that all the gravitational potential energy was converted into kinetic energy. We assume that there are no energy losses into heat or friction, or the collision of the air particles when you fall. We're going to assume that there are no energy losses. So all gravitational potential energy is converted into kinetic energy. So we can say that the first statement can be EP lost is equal to EK gained, and we're going to say that this is because conservation of energy. Alright, so we know that gravitational potential energy was reduced by 283,500 joules, and because the parachutist was initially stationary, so when she jumps down, she starts gaining speed. So we can say that the initial kinetic energy was 0. So we can say because the gravitational energy was reduced by 283,500 joules, the EK gained was also 283,500 joules. So you know that EK is equal to half mv squared. And that means our mass, what was our mass again? Our mass was 63 kilograms. So our mass, so M equals to 63 kg. Our kinetic energy is equal to 283,500 joules. And our velocity we're trying to find. Right, so we can plug in our numbers. So we can say 283,500 is equal to half of 63 times v squared. So we can rearrange the formula. So we can say 283,500 times 2 divided by 63 whole thing square root will give us our velocity. So 283,500 times 2 divided by 63 square root of that. Okay, so our velocity comes to be 94.87 meters per second. So after the parachutist lost 283,500 joules, the speed gained was 94.87 meters per second. However, in real life, the actual speed is going to be lower than this, and this is due to some energy being lost as heat and friction, which was not accounted for in the calculation. But however, in the calculation, because we're assuming simplicity, the answer comes out to be the maximum speed gain would be 94.87 meters per second. For this question, it's a tricky question actually. Could either be an excellence or a merit grade. Could be either or. I think because last year this question was an excellence level question, I'm gonna assume that this year is also an excellence level question. So assuming you got your final answer as 94.87 meters per second, you'll get an excellence grade. To get a merit grade, merit grade. Merit grade could just be setting up an equation, perhaps. Setting up an equation for V. An achieved grade, maybe just, I'm not sure, but maybe just this statement, this whole statement here, maybe just this by itself could get you an achieved because you're stating your assumption that could potentially get an achieved. Yeah. I'm not too sure, and this is definitely, I'm not too sure, but because I don't have the assessment schedule releases sometime in May, so I'm not too sure if this is the actual marking criteria, but I'm going off previous year papers and estimating what grade boundaries for this paper. Alright, so that's it for this paper. I hope you guys enjoyed the video. If you did, please drop me a like. If you have any comments, please leave it down below. And I hope you all enjoyed, and I'll see you in the next one. Thank you.